Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to be talking about the different parts of circles. So to start off, I would suggest that you just kind of pause the video and just take a look at all of these and all of the definitions. That way you can kind of familiarize yourself with all of them. While there are a lot of them, we're going to focus on a few of them in this video in particular. And so let's take a look at them. So first off, we got the circumference, and we have an equation for it. So the circumference C is going to be equal to 2 pi r, where r is the radius. Now the circumference is literally just going to be kind of the length of this edge of the circle. So imagine the circle was made of string, and you kind of cut the string right here, and you laid the string down flat on the table. It would be how long that is. So that's our circumference. And then we've got ourselves our arc length. Now, the arc length is just going to be a portion of this string. It's just going to be a portion of the edge, right? It might be a third of it or a fourth of it. And that has its own equation. It's going to be S is equal to R times theta. Now, one of the important things to note here is that theta has to be in radians. So we'll keep that in mind. Now we can take a look at the area. So the area of a circle is just going to be pi r squared, where r is the radius. And then we might look at the area of a sector. Now, what do I mean by a sector? A sector is just going to be a portion of the circle. So instead of the area of the whole circle, it's just going to be the area of one of these little slices. Now, we're given an equation for this, and it's going to be the area of a sector is 1/2 times r squared times theta. And again, we have to take note of theta. It needs to be in radians. So, with all that said, let's go ahead and try out a few problems. So looking at number 1, we are given a circle with a radius of 4 inches, and we want to find the exact circumference and area. So, well, we don't have to. Let's just go ahead and draw a sketch. Okay, so now that we've gotten our sketch, we can kind of get a better idea of what it is that we're actually trying to do. So first off, we want to find the circumference. So we want to find the entire length of this outside edge. So let's go ahead and write down the equation for that. We know that the circumference, C, is going to be equal to 2 pi r. And so we've got everything that we need. Let's just go ahead and plug it in. So C is going to be equal to 2 times pi, and then our radius is going to be 4 inches. Multiply it together. We're going to have C equals 8 pi inches. Now, we're going to leave it like this instead of trying to plug this into our calculator. And the reason we're going to do that is because we want the exact circumference. If we think about it, pi is a never-ending number, right? It's like 3.1415 ... and it goes on forever. Now, realistically, my calculator cannot hold all of those infinite digits. So at some point, it's going to chop it off, and I'm only going to look at 10 or 20 digits. While those digits that are being cut off are, for the most part, insignificant, technically, they're still important. And if we do truncate it, we cut it off, we're not going to get the exact value. And so, to avoid that, we just leave it as 8 times pi. So, anytime we're looking for an exact number, typically we don't want to plug things into our calculator because it'll chop off some decimal. So, now that we've got that covered, let's go ahead and check out the second part of the question. It's saying that we want to find the area. Now, the area of a circle is going to be pi times r squared. And so, again, we have everything already, so we can just plug it in. A is equal to pi times r squared. Well, r is 4 inches. And so, we have that A is going to be equal to 16 pi inches squared. And again, we're just going to leave it as 16 times pi because we want the exact number. Now let's head on down to number 2. So number 2 says, given a circle with a diameter of 8.2 inches, find the arc length and the area of a sector with a central angle of 35 degrees. Now this time it's telling us to round to 2 decimals, so we're actually going to be plugging things into our calculator here. First off, let's take note of what we were given in the problem. So we're told that the diameter D is equal to 8.2 inches. And then we're also told that our central angle is 35 degrees. So we can say theta equals 35 degrees. Now, let's take a look at what the problem is asking us. It wants us to find the arc length and the area of a sector. And so let's go ahead and write down those equations real quick. So we know that the arc length S is going to be equal to r times theta. And then we also know that the area of a sector is going to be A equals 1/2 r squared times theta. However, we have to be careful here. We need to remember that our theta needs to be in radians, not degrees. What were we given? We were given our theta in degrees. So we're going to have to convert that to radians before we can do anything. On top of that, in both of our equations, we're dealing with a radius, not with a diameter. So we have to find our radius from our diameter first. So let's go ahead and deal with those two things, and then we can actually start plugging things into our formulas. So starting out with our diameter, we know that our radius is going to be half of that. So 8.2 divided by 2 is going to be 4.1. So immediately we get our radius as 4.1 inches. And now we're going to convert our theta from degrees to radians. So we know that theta equals 35 degrees. How do I convert it to radians? Well, I'm going to multiply by pi divided by 180 degrees. And now we can kind of see that there's a degrees on top and on bottom. And so the degrees will kind of cancel each other out. And so I'm literally just going to leave this as 35 pi divided by 180. Now that we have these two things, we can go ahead and start plugging them into our formulas. So let's go ahead and figure out our arc length. So S is equal to r theta. So S equals 4.1 inches times 35 pi divided by 180. And if we plug that into our calculator, we are going to get that S is approximately 2.50 inches. And so that is our answer. Now, moving on to the second part, we can plug this in. So we know that the area of a sector is going to be 1/2 times r squared. Well, this is going to be 4.1 inches, quantity squared, and then times theta, which again will be 35 pi divided by 180. And now we just get to plug it into our calculator. So A is going to be approximately 5.13 inches squared. And so we finished our problem. Let's move on down to number 3. Number 3 is asking us to find the exact area of a sector of a circle that has radius 4 feet and an arc length of 6 pi feet. So again, let's take note of what we have. We have that our radius is equal to 4 feet, and then we know that our arc length, S, is equal to 6 pi feet. Now, we're trying to find the area of a sector, so let's go ahead and write down the equation for that. So we have A equals 1/2 r squared times theta. And so, I would like to be able to just plug things in like we did in the previous problem. However, we run into an issue. I know what r is, right, because we're given it. However, I don't know what theta is. So, what do? Well, we have to look at what we were given and try to figure out some extra information from it. Now, I can't really figure anything else from my radius since it's just one value. However, we were also given the arc length. And so, I know that there's an equation for arc length that involves theta. So, let's try writing that down real quick and see if maybe we can find theta from that. So let's go ahead and move this to the side. Now, our equation for arc length is S equals r times theta. And so now we get to think, all right, can I find theta from this? Well, I know what S is, right? It's 6 pi feet. And I know what r is. It's 4 feet. So the only thing that I don't know is theta. Therefore, I can actually solve for it. I can get theta equals S divided by r. So let's go ahead and do that. We know that theta is going to be S divided by r. Plugging things in, we have theta equals 6 pi feet divided by 4 feet. And again, we've got our units kind of canceling out with each other. And so we're just going to be left with radians, which is good because we're dealing with an angle. So simplifying this out, we're going to get theta equals 3 pi divided by 2. Now that I have theta and I have my r, I can plug both of those into my area equation and we can actually find the area of this sector. So we have area equals 1/2 times r squared, so 4 feet, quantity squared, and then times theta, which is 3 pi over 2. This then becomes a equals 1/2 times 16 feet squared times 3/2 pi. Now we could plug all this into a calculator, but we don't want to because the question is asking for an exact area. So we'll just leave pi as it is and we'll multiply all the numbers in front of it. So we're going to have a equals 1/2 times 16 is 8, and then 8 times 3/2 is going to be 24 divided by 2. 24 divided by 2 is 12, and so we get 12 pi feet squared. And that is the area of our sector. Well, that's going to do it for this video, and I hope to see you in the next one.